Hello everyone, today we are going to see about the fourth chapter in first BSc Physics, that is undamped, damped and forced oscillations. Okay, my name is Prakash. I am working as a lecturer in the Department of Physics in K.B.N Degree College. Without wasting much time, let us get into the session. In this session we are going to talk about what is periodic motion, what is the example for periodic motion, and then oscillatory motion, what is meant by simple harmonic oscillator, and then we are going to see what are the differences between damped and undamped oscillations, and then we are going to see what are the differences between free and forced vibrations, and then what is logarithmic decrement and relaxation time. And the last one is about the quality factor. What is the equation that explains the quality factor? Okay. Now the first session is about the periodic motion, right? Okay. What is meant by periodic motion? A motion which repeats itself. Okay. A motion which repeats itself after equal intervals of time is called as periodic motion. Okay. The path or the motion that repeat itself after an equal intervals of time is called periodic motion. Okay, it is also called as harmonic motion. The example for the periodic motion is the spin of earth, and the earth revolves around the sun is an example for periodic motion, and the motion of satellites is also an example for the periodic motion. Okay, here you can see that the earth moves around the sun. This path, Earth moves around the sun in an elliptical orbit, right? This is an example for the periodic motion, or also called as harmonic motion. The next one is about the oscillatory motion. What is meant by oscillatory motion? Okay, a body or a particle. Okay, whether it is a body or a particle moves back and forth or to and fro repeatedly about the mean position. Particle or body that moves to and fro repeatedly about a mean position is called as the oscillatory motion. It is also called as the vibratory motion. The example for the oscillatory motion is the pendulum of clock. In this diagram you can see the pendulum of clock moves back and forth repeatedly about the mean position. This is the example for the oscillatory motion. The next one is about the periodic time. Okay, what is meant by periodic time? Okay, remember the periodic time in oscillations is represented by capital T. Okay, the periodic time of an oscillatory motion, it is defined for an oscillatory motion. It is defined as the time taken for one oscillation. Okay, the time taken for one oscillation is called as the periodic time. Okay, in this diagram you can see the time, the number of revolutions. Okay, the time taken to complete one revolution or one oscillation or one cycle is called as periodic time. Okay, the next one is about the frequency. Okay, we all know that the frequency is represented by N or V. Okay, the frequency is defined as the number of oscillations in 1 second, or the number of cycles in 1 second, or we can say in other words that number of revolutions in 1 second. Okay, it is also reciprocal of time period. Okay, here you can see that it is represented in periodic time and equal to 1 by T, where T is the periodic time, cycles per second. Okay, the frequency is defined as the number of oscillations in 1 second or number of cycles in 1 second. Okay, in this diagram you can see that the number of cycles that can taking place in 1 second is defined as the frequency. The next one is about the displacement. We all know about this displacement very well. Okay, the distance of the particle in any direction from the equilibrium position at any instant is called the displacement of the particle at that instant. Let it be any instant, the distance of the particle in any direction, let it be any direction from the equilibrium position is called the displacement. In this diagram you can see that the blue color path which is taken as the path taken is called the distance, and the shortest distance is called as the displacement. Okay, now we are going to the next topic, which is given by amplitude. Now what do you mean by amplitude? The maximum displacement or the distance between the equilibrium position and the extreme position is known as amplitude A of the oscillation, or we can say maximum height of the wave, or you can say the maximum height of a crust or a trough is called the amplitude. Or in physics terms we can say that the maximum displacement or the distance between the equilibrium position and the extreme position is known as amplitude. Okay. In this diagram you can see the maximum height of a wave is known as the amplitude. It is represented by small a. The next one is about the phase. The previous terms you already listened somewhere, but this is somewhat a new term, phase. What do you mean by phase? The phase of an oscillatory particle at any instant, let it be any instant, the phase defines the state of the particle as regards its position and direction of motion at that instant. From this what we can say, the phase of an oscillatory particle defines the state of the particle, its position and direction of the motion also. Okay, the phase of an oscillatory particle defines the state, the position and the direction of motion of the particle at any instant is called phase. No, this is what the phase is. Phase 0 degrees, 90, 180, 280. Okay, it is represented in sine wave. Now we are going to talk about the restoring force. The restoring force. In equilibrium position of the oscillating particle, no net force acts on it. In equilibrium position, nothing but the rest. The oscillating particle will not have any net force acting on it. You can see, but when you apply an external force, the restoring force will always acts towards the fixed point. Okay, the restoring force always acts towards the fixed point. Okay, here you can see from equilibrium position the restoring force is acting towards a fixed point. When the particle displaced from its equilibrium position, in this diagram you can see, when a particle is displaced from its equilibrium position, a periodic force acts on it in such a direction as to bring the particle to its equilibrium position. Okay, when the particle is displaced from the equilibrium position, a periodic force acts on it in such a direction as to bring the particle to the equilibrium position. This is called as the restoring force. It is given by capital F. Okay, the force is directly proportional to the displacement of the particle from the equilibrium position. Okay, F is directly proportional to x, and it is represented with negative sign. Negative sign indicates that the force is acting towards the fixed point. So we can say that F is directly proportional to minus x. With the constant of proportionality, we can say that F is equal to minus kx, where k is the proportionality constant. So here you can see the example of a simple pendulum. Now the main topic of the important essay of third unit, so called fourth unit, simple harmonic motion. It is also called as SHM. Okay, what do you mean by simple harmonic motion? You can see this. This is a special type of periodic motion in which the body moves again and again over the same path about a fixed point. Okay, This is a special type of periodic motion in which the body moves again and again over the same path about a fixed point. Okay. It is defined as, the simple harmonic motion is defined as the motion of an oscillatory particle which is acted upon by a restoring force which is directly proportional to the displacement but opposite to in its direction. Okay, I repeat, it is defined as, nothing but the simple harmonic motion is defined as the motion of an oscillatory particle which is acted upon by restoring force which is directly proportional to the displacement but opposite to its direction. So if I say that F is the restoring force which is acting and X is the displacement of the particle from the equilibrium position, and opposite sign indicates the displacement of the particle towards the fixed point. So you can say that F is equal to minus kx in simple harmonic motion. So here you can see the motion of the oscillating particle, nothing but the block which is acted upon by a restoring force, okay, which is directly proportional to the displacement. Okay, this is what the simple harmonic motion is. Now coming to the characteristics of simple harmonic motion, there are 4 characteristics that determines the simple harmonic motion, nothing but SHM. The first one is the motion is periodic. Okay, the motion should be periodic. The second one is the motion is along a straight line about the mean or equilibrium position. The motion is along a straight line about the mean or equilibrium position. The next one is the acceleration is proportional to displacement. Okay, the acceleration is proportional to displacement. And the last characteristics of simple harmonic motion is the acceleration is directed towards the mean or equilibrium position. The acceleration is directed towards the mean or equilibrium position. Okay, now we are going to see what is the difference between damped and undamped oscillator. Okay, we can list out the differences between damped and undamped oscillator. Here you can see the first point is the amplitude of a damped oscillator gradually decreases. The amplitude will gradually decrease in a damped oscillator. But coming to the undamped oscillator, remember the undamped oscillator is also called as ideal oscillator. What? Undamped oscillator is also called as ideal oscillator. Okay, in the undamped oscillator, the amplitude of oscillation remains constant for infinite time. Coming to damped oscillator, the amplitude decreases gradually, but in undamped oscillator, the amplitude remains same for an infinite time. Okay. So coming to the second difference, the frequency of damped oscillator is independent of mass, shape, and elasticity of a body. Okay, the frequency doesn't depend upon the mass, shape, and elasticity. But coming to the undamped oscillator, the frequency depend upon the mass, shape, and elasticity of the body. The ideal oscillator, in ideal oscillator, the frequency of oscillation depends upon the mass, shape, and elasticity of a body. And the third difference is in damped oscillator, the frictional force, it depends on frictional force and damping force. Okay, in damping oscillator, it depends on frictional force or damping force. Coming to the undamped oscillator, it is independent of frictional force and damping force. Okay, it is independent. The ideal oscillator is independent of frictional force and damping force. And the fourth difference is the amplitude of damped oscillator always small. The amplitude is always small. Okay, coming to the undamped oscillator, the amplitude of oscillation may be small or big. We can't say that it is small. Sometimes it may be big. So in damped oscillator, the amplitude of damped oscillation will always be small. Coming to the undamped oscillator or ideal oscillator, the amplitude of oscillation may be small or sometimes it may be big. Okay, these are the list of differences between the damped oscillator and undamped oscillator. Remember, undamped oscillator is also called as ideal oscillator. The next topic is about the free and forced vibrations. What are the, in a similar way as compared with the damped and undamped oscillations, we are going to see what are the differences between free vibrations and forced vibrations. Okay, these are the list that shows the differences between free and forced vibration. Here see, you can see the first point. Free vibrations takes place under the influence of elastic forces. Okay, no external force will act on a body or a particle, but the vibration takes place under the influence of elastic forces. But coming to the forced vibrations, the vibration takes place by the application of external force. The vibrations which takes by the application of external force are called forced vibrations. Okay, coming to the second difference between free vibrations and forced vibrations. In free vibrations, the free vibrations, the damping effect, the frictional forces will affect the free vibrations, so that the free vibrations will comes to rest, will die in a course of time. Okay, in free vibrations, the damping effect or the frictional forces will die in a course of time. But coming to the forced vibrations, the forced vibration persists continuous as long as the applied periodic force acts on the body. As long as the applied periodic force acts on the body, the vibrations will continue. Okay. Now coming to the third difference between free vibrations and forced vibrations, the frequency of free vibrations depends upon the mass, shape and elasticity of the body. Okay, the frequency depends upon the mass, shape and size and elasticity of the body in free vibrations. But coming to the forced vibration, it is independent of mass, shape and elasticity of a body, but it depends upon the frequency of the periodic force. Okay, it depends upon the frequency of applied periodic force. Now coming to the last difference between free and forced vibrations, free vibrations may occur any amplitude, either small or big. Okay, free vibrations may occur with any amplitude, whether it may be small or big. But coming to the forced vibrations, the amplitude is always small, but except in the case of resonance. Except in the case of resonance, the forced vibrations amplitude will always be small, but coming to the resonance, the amplitude is big. Okay, these are the list that shows the differences between free and forced vibrations. Now coming to the next topic, that is logarithmic decrement. Okay, logarithmic decrement. The logarithmic decrement is defined as the natural logarithm of the ratio between the two successful maximum amplitudes which are separated by one period. Okay, the logarithmic decrement is defined as the natural logarithm of the ratio between the two successive maximum amplitude. It takes place between only the two successive maximum amplitude which are separated by one period. Okay, the logarithmic decrement is given by the symbol lambda. So lambda is equal to log A0 by A1 to the base C, where A0 and A1 are the amplitudes. Okay, it will be equal to log A1 by A2 to the base C, and the value is equal to the log A2 by A3 to the base E, where lambda is called as logarithmic decrement. The next topic is about the relaxation time. The relaxation time is defined as the time taken for the total mechanical energy to decay to 1 by E of its original value. Okay, repeat, the relaxation time is defined as the time taken for total mechanical energy to decay to 1 by E of its original value is called as the relaxation time. It is given by relation E is equal to E0 by E. As I say, it will be decay to 1 by E when t is equal to tau. the tau is called as the relaxation time. Okay, tau is called as relaxation time. And the last topic in this today's session is about the quality factor. The quality factor is defined as the 2 pi times of the ratio of the energy stored in the system to the energy lost per second. Okay, I repeat, it is defined as 2 pi times of, in this equation you can see Q is given by quality factor. Q is equal to 2 pi times of the ratio of energy stored in system to the energy lost per second, where Q is the quality factor. Okay, thank you.